Greetings and welcome to another lecture in psychopathology. We're continuing with chapter 14 covering the neurocognitive disorders. And so what we're going to cover here is what is called a major neurocognitive disorder. Actually, there's a number of these that we're going to be talking about. Some of them are caused by exterior factors, some by interior. There's a lot of them. But generally what these are called, or they used to be called anyway, were the dementias. And dementia essentially, in some ways you can think of it as a delirium that lasts a really long time. But what dementias have is real problems with cognition, real problems with thought. Now, just like delirium, this is a hugely broad category. There are at least 50 disorders that can cause this. And those are just the disorders. But it can also be caused, as I said, by strokes, both ischemic and hemorrhagic, can be caused by tumors, by malnutrition, head injury, anoxia, which is basically oxygen deprivation, poisoning. My goodness, there's lots of these. There's some suggestion that one might be caused by a parasite. There's all sorts of things that cause dementias, that cause major neurocognitive disorder. And I'm going to talk about some of the most common. The first is Parkinson's disease. Parkinson's disease is the second most common dementia or major neurocognitive disorder. It is more common in men than women. Unlike something like Alzheimer's, I think Alzheimer's is more of a 50-50. And the older you get, the more likely that you will have this. Again, this is similar to, other dementias like Alzheimer's disease. Now, how this isn't necessarily similar is that Parkinson's disease involves something fairly specific. For the most part, we're talking about motor symptoms, problems with movement. If you've seen somebody with Parkinson's disease, then you probably notice that they have a tremor. The tremor is just a shaking. They're shaking, they're tremoring. It can start out sometimes with numbness, and it just gets worse and worse and worse and worse. It's another progressive disease. And it seems to be related to a particular part of the brain called the substantia nigra pathway. Now, substantia nigra means dark substance or black substance. And it's so called because the cell bodies here are much darker gray, almost black, than you would find in much of the rest of the brain. Most of the brain is sort of a gray color. We have darker gray cell bodies, and we have lighter gray myelinated axons. But the substantia nigra pathway is very, very dark. It runs from the midbrain up toward the motor cortex, and we know that it is very much involved in movement. And we also know that it involves the neurotransmitter dopamine. In part because one of the ways to treat Parkinson's is to increase the amount of dopamine in the brain, which increases voluntary movement, decreases the tremoring, but it can also have all sorts of other rather unpleasant side effects. Now, in addition to the tremoring with Parkinson's disease, one might also find hallucinations and delusions. In that people with Parkinson's can wind up, seeing things or hearing things that aren't there, or believing things that aren't true. It can definitely do a number on thought and not just movement. Particularly later on in the disorder, it could really get involved in real problems with thought and thinking. Again, somewhat similarly to Alzheimer's, the younger a person is when they get it, the more likely it is that there's some sort of genetic cause. Now, we don't know for sure, but it's possible that people with this genetic predisposition, they may simply have fewer substantia nigral neurons than others have. So that as time passes and neurons naturally die, they wind up falling below that particular level, whatever that level is, to go into Parkinson's faster than people might normally. This would also then make sense because the people who develop at an older age, generally, it's more of an environmental thing. There are some environmental things that are linked with Parkinson's disease. Certain drugs that can be taken might interfere with the substantia nigra. There's some evidence that environmental pollutants, particularly those near a paper mill or a pulp mill, may indeed increase the chance of Parkinson's disease. But so does living, quite frankly. Because as you live, neurons die. Even neurons as well protected as those in the brain. They just die. They die naturally. And as I mentioned before, in the brain, they generally aren't replaced. And so the older you are, the more likely you are to develop these tremors. Now, this can be treated with, as I mentioned before, with dopaminergic drugs, with drugs that increase the amount of dopamine. You tend to have some fairly nasty side effects here, though, also. We were talking about what can happen with people who increase dopamine. We were talking about, for instance, stimulant overdoses. We talked about cocaine psychosis or meth psychosis. And the same sort of thing can happen here. We talk about hallucinations and delusions, and the hallucinations and delusions can also be caused by the treatment. And what also might often be caused by the treatment is people just can't stop moving. It's not the same as tremoring. The tremoring is very interesting because in some ways, as Parkinson's advances, the person doesn't wind up just flailing all over the place. What happens is actually the tremors become so strong and so constant that it's like they freeze in place. Their muscles are tense. All the muscles are tense, and so they're less, uncoordinated constant movement than just frozen. And in fact, the medication can cause people then to be able to move. But sometimes the medication causes them to move too much. The actor Michael J. Fox, for instance, has developed Parkinson's. He was diagnosed at early case back in the early 90s when I believe he was in his 30s. And he is still working as an actor as of the date of this recording, which is 2020. And the thing is, though, a lot of times, for instance, in interviews, he's constantly moving. He's moving his shoulders, he's moving his head, he's moving his hands and sort of thing. It's not tremoring, it's movement. What's doing that is not the disorder, it's the medication that he's taken to be able to move. Because without the medication, he's pretty much frozen and can't do a whole lot of anything. Now, other things that might treat this include deep brain stimulation. There's been some research looking at replacing that substantia nigra pathway with electrodes, essentially. And there's actually been some interesting results of it, again, as of this date. Exercise sometimes helps. It can help, regroove those pathways into what you have next, perhaps might be a way to think about it. And stem cells have also been used, very preliminarily, but they have been used to possibly replace this pathway. A stem cell is an undifferentiated cell. It is a cell that can become anything. Generally, we think of stem cells. The most flexible stem cells come from fertilized eggs. Because these human fertilized eggs, of course, those cells, we start with one cell and wind up with a human being, and so those cells have the potential to become anything because they do become anything. Eventually, when they generalize and become brain and bone and muscle and organ and whatever, then they're not really generalizable anymore. Although even adults have some stem cells, for instance, in fat, which is probably used to make more fat cells, which most of us don't need. So the idea is to introduce stem cells into this pathway, into this denuded pathway, in the hope that the stem cells will regrow and take over some of the functions of these lost neurons. And preliminary results have been promising. Not promising enough that it is in general use, but promising enough that there's definitely more research going on, particularly in places where this sort of stem cell research is legal, which I don't believe is the United States. So it will be very interesting to see what occurs with this in the future. Another dementia, another major neurocognitive disorder is Huntington's disease. Also known as Huntington's chorea, I believe it's pronounced. It's rare. It's very rare. And that's a good thing, because this is the exception to the disorders tend to be polygenic rule. This disorder is not polygenic. This disorder is caused by one mutated gene. More about that later. What is it? Essentially, it's a loss of brain neurons, starting probably pretty early, probably 30s, usually not noticeable until 40s, it causing what's called this chorea, which is involuntary or irregular movements. Again, there's a lot of it, but the real problem is the cognitive problems. People wind up In some ways, it's almost like an Alzheimer's. People wind up with problems regulating emotions. They get very irritable. They get very volatile. They have problems thinking. They have problems recognizing people. They have problems controlling themselves. It's pretty nasty. Generally, the symptoms start to show up around the age of 40, and it is invariably fatal. We have no cure for this. We have no treatment for it. We have no way to prevent it. Well, there's one way to prevent it, but it's rather drastic. And once the person has the disorder, there's not anything that we can do about it. As I mentioned before, this is caused by one gene, and what makes it even trickier is it's a dominant gene. A dominant gene, remember, means that if you have one copy of it, no matter what your other copy is, you will show that gene. So if a person has one parent who winds up developing Huntington's disease and they inherit that gene from the parent, they will get that disease 100% absolute certainty. If you have the disease, you have the gene, you're going to get it. In the past, people didn't generally know if a parent had the disease, for instance, until they themselves were in their 20s, and the parents were in their 40s, say, and the parents had already had children. People couldn't really wait to see whether or not the disorder started to show up before they decided to have children, particularly women. Men, perhaps, but particularly women. And so what people would often do is if they had a parent who developed it, they simply themselves would not have children, to not run the risk of passing that down to their offspring. And about the only way that we can deal with this disorder is preventing it from happening. Now there is indeed a genetic test that can tell a person whether or not they have this gene. And this brings up a very interesting question we're going to be running into more and more, which is, if you knew that one of your parents had had Huntington's disease, and you had a chance of inheriting this gene, and you're 20, would you want to know? Would you want to take that test? There's no right or wrong answer. It depends on the individual. Some choose to know. So they know if they want to have children, it's going to be more difficult. They know they don't have to save up for retirement. They know they better give good health insurance. On the other hand, people who don't want to know probably just don't want to think. Every time, they forget something in their 30s, they're going to think, oh my God, here it is. And so they just choose to live as if they don't have it without learning. There is no right or wrong answer. But there is a way for a person who carries the gene to ensure that their children do not carry it, and that is to do in vitro fertilization. It is possible to harvest a number of eggs, fertilize them with sperm in vitro, and then allow those fertilized eggs to divide until they're usually, I think, at either the 8 or the 16 cell stage, and then remove one of those cells and do the Huntington's disease gene test on it. It won't hurt that developing embryo any to lose one cell at that point. And then the doctors will simply take the embryos that do not carry that gene and implant those, and do not implant the ones that do. And for those whose ethics and morals allow them to do that, that is a way to ensure that children will not carry this gene, that this gene will not be passed down to the next generation. But that's pretty much it. Like I said, this is not something that can be treated or slowed down or anything. And again, spend a minute thinking about this, since I'm going to end this tape right about here. If you had an option to take the test and to know that you were going to die a rather horrible lingering death by age of 50, would you choose to take that test or not? More and more, we're going to be able to test for things that we can't do anything about. And it's going to be a really interesting question to see whether or not people will want to be tested, whether or not people will want to know.